I'm going to tackle insect phylogeny up until complete metamorphosis. And I'm only going to cover the really big transitions, but they are the transitions that need to be talked about. So I'm going to show you a picture. That picture is missing so much. And I think it's because we know so much about green that we oversimplify red, okay? So I'm going to share my chart, and I color-coded it to their picture, okay? But I'm also going to talk about these and what morphological features cause these divides, because that's something interesting in all of this, is that there's always a physical feature that causes this kind of clumping and grouping, or this breaking, or this evolution. There's something that gets passed down, or something that gets modified as a mutation that goes with the group. Now, with insects, I think they're easier to argue evolution with, because there's a lot of orders that stop but didn't go extinct. And that's not the case with a lot of other vertebrates, okay? A lot of those leading up or transitional families don't exist anymore, but that is not the case in Hexapoda. So the first two divides all have to deal with one of the most important parts of an insect or Hexapoda, and that pretty much decides all of it, is the mouth, okay? You either have your mandibles inside your mouth in a pouch, or you have your mandibles outside the pouch, okay? And this becomes enteognathia and ectognathia. Enteo is the inside grouping, ectio is the outside grouping. So here you go, you got your 6 legs, you got your internal mouth, you've got your external mouth. The major radiation comes from the external. The groups in the internal still exist though. It should be noted that those groups are not considered insects either. And there's 3 main ones, okay, with lots of species in between them. The next grouping is the mouth joint, okay? So either you have 1 jaw joint, okay, or you have 2 jaw joints. And that is basically, where does the mandible connect to the back of the neck, the spine, essentially. But again, they don't have a spine, so it's just, where does the mandible connect? Does it have 2 joints? Does it have 1 joint? Okay? So you've got archaeognathia, which is the 1 joint, and you've got dicotylia, that one I practiced, and that is the 2 joints, okay? And we still haven't even gotten out of the red. That's literally, we are right now at the first red line. So they skipped a huge chunk of groups, okay? So once we get into the 2 joints, you get wings, okay? And you have either the wingless group or the winged group, okay? Winged group is insects proper. This is what we consider insects, okay? So you've got Aterygota and Pterygota, okay? And again, Aterygota still exists. These are what we call the silverfish, okay? Interestingly enough, right after Pterygota, okay, something really interesting happens in insect evolution, and that is metamorphosis, and that is full wings, okay? This is where it gets dicey, and this is where it gets controversial. This is the whole wings gill debate thing. But more importantly, wings and partial metamorphosis are linked. Good gosh. So there is something happening here, and it's not well understood, okay? It is, but it isn't. We look at the living extant orders and we have a pretty good idea of what happened, but what actually caused the radiations is speculative, okay? Because we don't know what caused wings. So because of that, there's this weirdness to it. For your reference again, I'm going to put the chart up again. We're at the first blue line now, finally. Okay, this divides into two groups, really, remaining living groups. There are in between extinct groups that we have very good records, fossil records for, because this all occurred in the Carboniferous. But we've got the Paleoptera and we got the Neoptera, okay? Paleoptera, the wings do not fold, okay? They very much sit horizontal or vertically next to each other. They don't fold in, okay? So think of this as the difference between a dragonfly and a moth, okay? The moth wings can bend. Beetles can bend and fold their wings underneath each other. Dragonflies and mayflies can't do that, okay? One other interesting divide here is aquatic nymph stage. Most of the Paleoptera are aquatic, okay? Well, the Neoptera, there's still some aquatic nymph stages, but they think that actually redeveloped, okay? And there is like one or two, this is where it gets awkward, okay? I refer to this as the dumpster fire of insect evolution, okay? Because there are two major groups, and the interconnection of those two groups is very, very speculative. Then you have the third major group, and we know way too much about it. Like, we're going there, okay? So you've got three groups, all right? You've got your Polyneopterid, your Paraneoptera, and then you've got Holoametabola or Endoperiopterygoda, okay? And matching the chart, everything in blue up to green is those two groupings, basically, okay? I think, and well, I know, okay, in entomology, we know a lot about Holoametabola. And what that basically means is complete metamorphosis. Okay, so that is your bees, your ants, your wasps, your butterflies, your caddisflies. It is anything that goes through a pupa stage. Your flies, you know, everything else is in those two groups. And those two groups, we understand really well why they're grouped together. We don't always understand the mechanisms behind it. Okay, and there is a lot of convergent evolution in those two groups, and there is a lot of rapid adaptations, okay? So it makes it very difficult to narrow down what trait came about and what reason. So I think that's why it's kind of a dumpster fire, is that, like, we understand complete metamorphosis so much better, and additionally they are the hugest chunk of what the visual, I mean, no, they're not the biggest chunk because basically beetles is in the other group, okay, but they're just so much more studied, okay, and they're easier to study in them. So I think that's why that chart makes up so much of it, is because it's, everybody loves butterflies, everybody loves bees. It's easy to figure that all out. Ants. Beetles are one of the few groups that are well studied, but they're in the dumpster fire, and that's because of metamorphosis and niche partitioning. So, and that's where a lot of it gets broken down by morphology, but again, we don't always know if it's convergent evolution or is it derived ancestral traits. It goes haywire. So there you go. There's my summation on major transitions to insect phylogeny and taxonomy.